Good day to you all. This question is extracted from Young Modulus. So we look at our step 1. Before we go into our step 1, let's take a look at our parameters. In our parameters, we have length. This length here is the original length, which is in 30 centimeter. The strain of the length is 30.5 centimeter, but we have the extension, which is 30.5 minus 30. That is the extension of the length, and in centimeter. We have our force. We were given our force, which is 300 Newton. Then we have the strain of energy. So the strain of energy here in Young Modulus, we have different ways of calculating strain of energy. So I'm going to use, so before I move further, let's go into step 1. Step 1, this is the length, original length, which is in 30 centimeter. As you can see, the length has not extended. Then if you look at step 2, we have 30 centimeter, the original length, then the extension, which is 0.5 centimeter. Then total, the strain of the extension, which is 30.5 centimeter. So that's for step 2. So if you are asked to calculate the extension, so the extension is simply going to be 0.5 centimeter in step 2, due to the fact that 30.5, which is the strain of the extension, minus the original length, which is 30 centimeter. So therefore giving us 0.5. Then if you look at step 3 says that energy. So we have energy, we have our formula for energy is half Ke square. This K is a constant. So, or we can use half Kx square. So if X is unknown, or we can use E. So K is constant here. Now we are given the force. The force is given to us, but our constant is not known. So constant for each strain of the original length and the strain of the extension is going to be different. So if you look at step 4, they say constant is K is equals to constant in the spring. So we have strain of energy is equals to half Ke square, that is 2, that is the E2, that is the strain of the extension, minus half Ke square, that is the E1, which is the original length, is equals to 5. And that is equals to step 5. So we have for length, which is length, original length 1, we have F is equals to Ke. There is a particular formula like this too, to determine the value of K. So we have our force, which is always 300 Newton. Then we have our K, which is unknown. Our E for length 1, which is 30 centimeter. So you convert your meter, 30 centimeter to meter. Therefore, you divide by 100 and multiply by 1 meter. So centimeter cancel centimeter is going to give us 0. That's gone. It's going to leave for us meter. So 30 divided by 100, that's 0.3. So if you make K the sort of formula and say 300 Newton in step 6, 300 Newton divided by 100 is going to give us 1000 Newton per meter, which is the value for K. So for E2, so we follow the same formula for the way we deal with step 6, and we deal with step 7 same way. Therefore, our value for K here is also equals to 983.6 Newton per meter. That's for step 7. Then we now said from step 5 above. Where is step 5? This is step 5, strain of energy. So we want to minus each energy at a different strain from each other. So we input this formula. The one is for E2. So strain of energy for E2, that is half 983.6. That is for E2 times. Then we have our extension. So our extension, or strain of extension, is 30.5 for E2. Then 30.5 divided by 100, because we have to change this to meter. So that's going to give us 0.305. Then you square it, minus 1/2 times 1000. That is our constant for L1. So then we have our 30, which is the original length, divided by 100, that's 0.3. You square it. So that's for step 8. Then strain of energy, the actual strain, if you calculate everything in step 8, if you solve the value. It's going to give us 45.75 for the E for the first one. Then the other one is going to give us 45 joule for the second one. If we subtract each other, you subtract the value, is going to give us 0.75 joule, which is for step 9 and which is our final answer. So that's that for that. Thanks.